In this video, we will learn about that quadratic equations might have complex roots. So we have to remember these 3 points that every polynomial of degree n has exactly n roots. For example, if we have a polynomial is equal to x minus 1 whole power 4, then its root will be x is equal to 1. But we will not say that it's only one root. We will count it this root as 4 times, right? This is the main point. First point we have to remember that every polynomial of degree n has exactly n number of roots. And second is that in a quadratic equation, for example, the quadratic equation is ax squared plus bx plus c is equal to 0. If this condition is that b square minus 4ac, we will find its value and its answer is less than 0, then there are no real roots, but we have two complex roots, right? And we will do it by solving an example, so it will be clear for you. And third thing is that complex roots occur in conjugate form. So we have complex roots as we have discussed here in second point, and these complex roots they occur in conjugate form, in conjugate pairs. For example, is z is equal to x plus iota y is a root, then the second root will be x minus iota y, and x minus iota y is the conjugate of the first root, this thing. So these are the 3 main points we have to remember. First point, that quadratic equation might have complex roots, and how it will be, we will solve this by an example. Example is here, 2x square plus 2x plus 13 is given, and in this equation we have the value of a is 2, b is 2, c is 13. So by quadratic equation we can find the root by using this formula. This b square minus 4ac divided by 2. This is our quadratic formula, and we say this b square minus 4ac, this will be less than 0, its answer will, this is the condition, right? Then we have two complex roots. Now we will show it. In this equation you will put the values of a, b, c. (26 multiplied by 4) will be 104. And in next step you can write it here, 10 multiplied by 10 and minus 1. Here 10 multiplied by 10 will give you 10, and minus 1 under root will give you iota, right? Take 2 as common, minus 1 plus minus 5 iota divided by 4. So you can check, we have two roots of this equation. Simplify it, minus 1 by 2 plus minus 5 by 2 iota imaginary, right? So you can check, this is the form of x plus iota y, right? And we have two roots. One root will be minus 1 by 2 plus 5 by 2 iota, right? This is first root, and second root will be minus 1 by 2 minus 5 by 2 iota. So this is conjugate of this. And this thing we have discussed earlier, that A quadratic equations might have complex roots, and complex roots are like that. You can see it here. And in third point we have said that these roots, one root is conjugate of the other root, and we have proved it by example here. You can check it. And by using these 3 points we can find also another question, that find the quadratic equation with real coefficients if that has complex root. Only one root is given, complex root, and as we have discussed earlier that if one root is given then the other root will be its conjugate, right? So we will say the other root will be in the solution. You can say if one root is 2 plus 3 iota, then the other root will be 2 minus 3 iota, right? And if these are the roots, then you know we can write them x minus one root is 2 plus 3 iota, like that. Their multiplication, no conjugate, sorry, minus 3 iota. Their multiplication is equal to 0 if they are the roots of the quadratic equation, right? Remember, if one root is given, then its conjugate will be the second root. And if these are the roots, then we can write it x minus 1 and x minus 2 is equal to 0. This is the rule that we can equate equal to 0. We can put, if there is one thing is the root of the given equation, then we can write it here. For example, if somebody is saying that for this equation 1 is the root, then we will write x minus 1 is equal to 0. So I am using this terminology here. First root x minus this multiply by x minus second root, that is equal to 0. No, I am going to simplify it. What is the simplification? You have to multiply them, and I am going to multiply it here, and the multiplication will be the same as we have done in the multiplication of brackets, single brackets rule. First will become x square minus this x will multiply by this, and this x will multiply by this, 2 minus 3 iota x minus this will multiply by this, and then this will multiply by this, plus sign. All are equal to 0. Now we will simplify it here. X square minus minus 2x. Minus 2x will give you minus 4x. This will cancel this. In place of iota square I will use minus 1. So this is the quadratic form or quadratic equation if one of the complex root is given. How can we find quadratic equation with real coefficients that has complex root? Only one root is given. So we have discussed that if one root is given, then the other root of complex number will be its conjugate. So if 2 plus 3 iota is one root, then the other root will be its conjugate, which is 2 minus 3 iota. I will write here. And this is the method that if the root is given, we can write it here, x minus this multiply x minus second root, both multiplication is equal to 0. And now we will multiply these things, simplify them, which are cut them, and use the definition of iota square, which is equal to -1, and then you can get this equation, and this is the quadratic equation, right? It's so simple. So in this way, if one complex root is given, you can find the quadratic equation with the help of that complex root.